Welcome back. We're going to talk about linear coefficients, the last type of problem in this section. Okay, so we've got t plus x plus 2 dx plus 3t minus x minus 6 dt equals 0. And really what we really want to do is we just want to try to get rid of this 2 and this 6. If those weren't there, we could make this into a homogeneous equation. Okay, so we want to aim to get rid of or suppress the 2 and the negative 6. Okay, so we're going to say, all right, let's let u equal t plus h and v equal x plus k. That means t equals u minus h, x equals v minus k. All right, and what we want to have is we want to have this first term, we want to have as u plus v. Now dx is going to be dv plus 3u minus v du, because du and dt are the same, should equal 0. Okay, so now let's go ahead first and find h and k, but then we'll later on solve this. So we'll put this to the side. So let's go ahead and find h and k first, just so that we have them. But really, yeah, we'll find them first. So we need t is u minus h plus x v minus k plus 2 should equal u plus v. Okay, so that's this first coefficient, right? This is t plus x minus 2 should equal u plus v. Okay, so this gives us h plus k equals 2. The second equation is going to be 3 u minus h minus v minus k minus 6 should equal 3u minus v. Okay, so we're going to get negative 3h plus k should equal 6. Okay, so now that's just a matter of man, I'm stupid sometimes. H plus k equals 2, negative 3h plus k equals 6. You guys aren't allowed to comment on that. You guys are probably like, you stupid all the time. So 3h plus 3k equals 6, negative 3h plus k equals 6, 4k equals 12, k equals 3. If k equals 3, then h is going to, of course, equal negative 1. Okay, so our substitution, just to sort of keep it in track, is u equals t minus 1, v equals x plus 3. Okay, so we're just going to keep that around. Now, how do we solve this equation? Okay, well, let's put it in terms of, we can put it in terms of du over dv or dv over du. It really does not matter which one we let be the dependent and independent variable at this point. So let's just go ahead, let's say u is the independent variable. So I'm going to write this as, dv over du equals v minus 3u over u plus v. Now, when I do homogeneous, remember, I want to factor so that it's independent over dependent over independent. Okay, if you look back to our beginning, oh, there. Okay, dy over dx, you had the y over x here. Okay, did the same thing. dy over d theta, we put y over theta. So now here, we're gonna let's call it z. I like z for whatever reason. Z equals v over u. Okay, so we're gonna factor out the u. dv du equals, we're gonna get z minus 3 over 1 minus z, right? Do you see why? The v over u is z, u over u is 1, u over u here is 1, v over u is z. Let me change this. uz equals v. Let's take the derivative with respect to u of that. So we get u dz du plus z equals dv du. So u dz du plus z equals z minus 3 over 1 minus z. Oh, okay. Still have to solve this one, don't we? Okay, so let's go for it. Yeah, plenty of space. Okay. So, u dz du equals z minus 3 over 1 minus z minus z. Okay, so u dz du equals, I'm going to write this in terms of a fraction. So I'm going to write this as z minus 3 minus z times 1 minus z over 1 minus z. U dz du equals, let's see, z minus z cancels, z squared minus 3. Wait, no way. Yes, z squared minus 3 over 1 minus z. Okay. Okay. So now, once we have z squared minus 3 over 1 minus z, let me write this instead like this. dz over du equals negative z squared minus 3 over z minus 1 with a 1 over u. Okay, so now this is a separable equation. Z minus 1 over z squared minus 3 dz equals negative du over u. Okay, and now it just becomes a matter of how good am I at integrating. Oh, wow, running out of space. But it's not that hard. So let's write okay, the integral z minus 1 over z squared minus 3 dz equals z over z squared minus 3 dz minus 1 over z squared minus 3 integral dz. Okay. This integral is going to be the arctan, I'm sorry, 1/2 the natural log of z squared minus 3. Right? Because you're just going to let u, you're just going to let u equals z squared minus 3. Okay. And this one's like some arctan, or let me just do a trigonometry, or I'm going to really be a dick. Not really. But sorry about that language. Oh, I'm fired now. 1 over z squared minus 3 equals a over z plus root 3 plus b over z minus root 3. We're going to do it by partial fractions. So 1 equals a z minus root 3 plus b z plus root 3. Okay, so if z equals root 3, then this term goes away, right? So you get 1 equals 2 root 3b. So b equals 1 over 2 root 3. And similarly, a equals negative 1 over 2 root 3. Okay? So this integral is going to be 1 over 2 root 3 times the natural log of z minus root 3 plus natural log of z plus root 3. Okay? Oh, hold on. So moving that over here, that's going to equal equals negative natural log of magnitude of u plus c. Z, remember, don't forget, z was, oh, this is ridiculous, v over u. Okay, let me make some space. Okay, like we said, no. So remember, z equals v over u, right? Oh, right, it was, let me find it. That was all the way up here, z equals v over u. Let me also remind ourselves that u and v were that. Okay, so we get 1/2 natural log of, let me write it this way first. V over u squared minus 3 plus 1 over 2 root 3 natural log of v over u minus root 3 plus natural log of v over u plus root 3 equals negative natural log of magnitude of u plus c. Now reminding ourselves that u is t minus 1 and v is x plus 3. I hope I haven't given anyone vertigo with all the scrolling up and back. If I have, then I'm sorry. Please have a bucket, a throw up bucket ready if you need to sometimes. 1/2 natural log. This is so that you all aren't going to Disney World. Because as I'm writing this, Disney has just opened and it's ridiculous that they did. So I'm just trying to give you excitement outside of Disney World so you don't have to go. Hopefully by the time you're watching this though, Disney World has closed again. So making my substitutions. I've been enclosed too long, I think. I'm ready to see people. But life is what it is. Never thought I'd say that. I'm just plugging these things back in to give us our final answer. I'm now trying to entertain myself. Oh, no, no, there. Okay. All right. There's your awesome answer. And that is it for today. Okay. I actually did this one in 2 sittings because I wasn't happy with my performance yesterday. And I'm starting to get frustrated with this one. Maybe I'll redo this one too someday. Probably not today.